We will now see what happens when we have multiple assignments to a variable. So first we have x1, assignment here, and then another one. X4 is used as an operand to this phi function. But how can we keep track of the previous version when we visit this vertex and want version x1? We will see soon how the Dominator tree is used for this in a very nice way. Before that, I will say what happens when we come to the end of a vertex. We can start here. Now we come to the end. We have processed all the 3 address code instructions, and we check in each successor if there is a phi function. In the successors here, there are no phi functions, so we skip that. However, when we come to this vertex, we see that the current version of x is x4. And then we check each successor. There are 2, obviously. And then we take the current value of x, which is x4, and replace the operand x with x4 at the appropriate position in this argument list. So in this case, there are 2 predecessors and there are 2 arguments, so we put x4 there. Here we put x4 in the first, since this is the first predecessor. That means we need to keep track of the order of the predecessors. Otherwise, we will have complete chaos. If we would accidentally get the x4 and x1 in the wrong order, then that will be very bad, obviously. So that must be avoided. When can that be a problem? It can be a problem when we remove a predecessor. So therefore, it's often a good idea, at least during development, to not only have the phi operand, but also a pointer to the vertex, so that any error in the compiler would be detected immediately. Then that can be skipped, that such checks when everything, or at least this, works perfectly. Okay, so let's continue. What we use, as we will see, is that we will have a stack. So when we come to an assignment, actually we draw the stack here. So each variable has a stack, and when we come to, well, first to this assignment, actually that assignment is not present in the intermediate code, so we will never see it. But when we come to this assignment, we push x1 there. And then when we use x, when we use x, then we check the top of the stack and take the version at the top of the stack. Okay, now we go down here and push x4. So we use that. And as we can expect, after we have visited this part of the Dominator tree, we will remove x4 and have x1 as the top of the stack. Let's see the next slide. Here we have introduced names to the vertices. So this is a part of the Dominator tree. S is the immediate dominator of each of these. So we can draw this stack again. And we have x1. Now we are in S, and we are here. And then when we have processed S, we visit each sorry, not successor, but well, we will visit each successor to look for phi functions, but we will go down to each child in the dominator tree. So we will go down to t, and there we push x4 and process everything there. When we're done, we look for phi functions in the successor vertices. When I say successor vertices, I mean those which are direct successors, so to speak, which have an edge from the current vertex. Okay, that was explained previously, but we replace x with x4 here. Okay, now when we are done with t, there is no child in the dominator tree of t. So what we do then is to pop this stack. Everything that was pushed in a vertex is then popped. So we do that. And now we are back to S and continue with the next child. Okay, this happens to be U in this figure, but let's take V instead, just to make this look nicer. Well, not nicer, but cooler, since it might imply that it's easier if we get to U first. Okay, but the algorithm handles this order as well. Okay, so X, we go down to V. What we have here is a new assignment, which is a phi function, so we push X5. Okay, what do we do with X5? Well, not so much there, but when we come to this, we replace the argument and put X5 there. Then we are finished with V, since it has no child in the dominator tree. Okay, so we pop X5. I mean, we just forget it. And then we go down to the next child in the dominator tree. That's U. Okay, here we use X1 and we take what's on the top of the stack. We use X and we take what's top on the stack of the stack, and that's X1. So we replace that X with X1. Then when we're finished with U, we look for successor vertices and in particular their phi functions. So we put X1 there. And then we will pop, when we go back to S, we will pop X1 as well.